Let's see the factors of resistance or factors affecting the resistance of a conductor. Now, conductor means when you put a wire, metallic wire. So this is a very thin wire. So you can take thick wire also. If you take the thick wire or if you magnify its image, okay. Now wires looks like this. Okay, it looks like a rod. Then it has a length. Okay, and if you see this front face, so it looks like a flat circular. Okay, so let this flat surface is A or area of this flat surface. Now this circular, that's why its area will be pi r square. R means pi means pi equals to 22 by 7, its value, and r means what? R means radius. Now factors of resistance. Number one, material. Okay, different materials. For example, copper, silver, anything. Okay, any conductors. So these conductors have different resistance. That's why it depends on the materials of a resistor or of a conductor. So now this factor is known as material. That means this is known as rho. It's like E, but its head is large head. And number two factor is length. Length of the wire. So in the bracket I have written small l. This length. If you increase the length, this resistance also increases. Okay. Number third is thickness of conductor. Thickness. Thickness means how much thick. What is this area? Okay. If the large area, okay, so its resistance will be different. If the small area, its resistance will be different. So now this thickness is known as area. Okay, so when you increase or decrease the area, the resistance also will be different. And number four is temperature of a conductor. Temperature, this is temperature T, capital letter T. Okay. Now if you see all this in terms of resistance or in mathematically, this material, okay, so number one was it depends on the materials. So if the resistance of this conductor is R, okay, if the resistance is R, then how these are related? Then resistance R may be proportional to the different types of material. Okay, so this is written as R is proportional to rho, or which is called properties of material, and length. Now when you increase the length, this R also increases. But here in the third, thickness, if the thickness increases or if the area is large, then the resistance will be decreases. That's why we have to write down here now in down. Okay, so or this is inversely proportional. Then when you find all this value, so this R will be equal to rho into L by A. A is area. Okay, and finally number four is temperature. So if the resistance is ohmic resistance, if you increase the temperature, okay, resistance also increases, and if you decrease the temperature, resistance also decreases. So this R is directly proportional to the T. That's why I have written here in numerator. So numerator means directly proportional. In denominator means inversely proportional. Okay, but if the resistance is non-ohmic, then this temperature may be up or it may be down. Okay, if the resistance increases, then temperature will decreases, or when temperature decreases, resistance will be increases. If the resistance is non-ohmic, that's why I have not written here now T. So if the temperature is fixed, okay, then resistance depends on this type of material, rho, and length, and its area A. So area is pi r square. So these are the four factors: material, length, thickness, and temperature of a conductor or wire.